In this lesson, we're going to talk about solution stoichiometry. And the beautiful part about this is it's a combination of something we already know, stoichiometry, maybe even love it, with what we just learned about solutions. So there's nothing new here, no new concepts, no new formulas. We're just going to combine some things that we already know. Let's review just a little bit about stoichiometry. Here's your stoichiometry roadmap, which shows us how to convert between the mass of one substance, and if we wish, we could get all the way to the mass of another substance using molar mass, the mole ratio from a balanced equation, and another molar mass. There is a bit of a shortcut. Well, not a shortcut. When we use solution stoichiometry problems, we'll be starting at the mole level, so you won't need to be converting from grams into moles initially. It'll already be in moles. Next, we're going to combine the molarity formula. Molarity equals moles over liters. And if we manipulate that equation a little bit, we get molarity times liters equals numbers of moles. We're also going to be using the list of solubility rules, which will be helpful in figuring out what is aqueous and what's not. Let's do a little warm-up. Let's say we've got a 550 milliliter solution with a concentration of 0.45 molar. Notice I don't need to tell you what is dissolved. It's not important. It's not necessary in order to answer this question. How many moles of solute are contained? Well, to figure that, we're going to use that manipulated molarity formula. Molarity times liters equals moles. We've got to convert from 550 milliliters into liters. That means divide by 1,000. If you do that, you get 0.55 liters. If we multiply that by the molarity of 0.45, we get 0.25 moles. Most solution stoichiometry problems will have you begin with this calculation. So that's why we did that warm-up. Now, let's try a more complete problem. I'm going to give you a full balanced equation. Aqueous calcium nitrate is mixed with aqueous lithium sulfate to produce 2 moles of aqueous lithium nitrate and 1 mole of solid calcium sulfate. Because of that S, we know that our solid precipitate is calcium sulfate. There's 4 parts to this problem. Part A, if the reactant solution that contained calcium nitrate had a volume of 1.1 liters and a concentration of 0.73 molar, calculate the number of moles of calcium nitrate present. B, if the calcium nitrate reacts along with excess lithium sulfate, according to the balanced equation, how many moles of calcium sulfate are expected to be produced? C, calculate the molar mass of the solid precipitate. D, calculate the number of grams of that solid precipitate that are expected to be produced. Let's tackle each of these parts one at a time. So, starting with part A. Part A was if the reactant solution that contained calcium nitrate had a volume of 1.1 liters and a concentration of 0.73 molar, calculate the number of moles. The molarity formula is helpful. If you take this molarity formula and multiply both sides by the number of liters of solution, we arrive at this formula. Molarity times liters equals moles. Our molarity in this case is 0.73. Our volume in liters is 1.1. So we're simply going to multiply. 0.73 times 1.1 equals 0.8. There's that many moles of calcium nitrate present in the initial solution. Part B, if the calcium nitrate reacts along with excess of the other reactant, how many moles of calcium sulfate are expected to be produced? Well, in the balanced equation, there's an implied coefficient of 1 for calcium nitrate and also an implied coefficient of 1 for calcium sulfate. We know that there's 0.8 moles of calcium nitrate. We're going to do a one-step stoichiometry problem. We're going to go from moles of substance A to moles of substance B using that 1-to-1 mole ratio that we had identified. 0.8 moles of calcium nitrate times 1 mole of calcium sulfate over 1 mole of calcium nitrate gives you a mathematically identical answer to what our input was, but it's in different units, moles of calcium sulfate. So that's really important and a worthwhile calculation. Question C, calculate the molar mass of calcium sulfate. This is important because we're going to need it to find the number of grams later on. To find this, use your periodic table. Take the time to look up calcium's atomic weight, sulfur's atomic weight, and oxygen's atomic weight. Round them to the 10th place. In the case of calcium, 40.1, sulfur, 32.1, and oxygen, 16.0. There's 1 atom of calcium, 1 of sulfur, and 4 of oxygen. Multiply across, and you get these numbers with a total of 136.2 grams per mole. Part D, calculate the number of grams of calcium sulfate that are expected to be produced. Grams. So we know the number of moles of calcium sulfate from part B. It was 0.8. And now we've got the molar mass from part C, and we're asked to find grams. Consider where we are on the stoichiometry roadmap. We've got 0.8 moles. We know the molar mass, 136.2, and we're asked to find the final mass. Write the conversion factors so that the moles of CaSO4 crosses out. So make sure it's 136.2 grams on top, 1 mole of CaSO4 on the bottom. We arrive at a final answer of 109 grams of CaSO4.